Hello everyone, welcome back again. My name is Jesse, and then in today's tutorial on SpaCy, we learn about similarities. So the similarities we learn about is semantic similarities, not syntax similarities. So the purpose of similarities is to help us to be able to do a lot of things, right? And then SpaCy gives us the opportunity to compare two different objects or several objects and check whether they are similar, right? And it does this by converting the words, the object into vectors, word vectors, and then compares them. The use case or the usefulness of this is to help us be able to build recommendation systems. So in all data science, we have three main aspects. We have descriptive, we have predictive, and then we have prescriptive, right? So descriptive is just normal EDA, and then predictive is when you are building models, you are building like machine learning, most of these things. And then prescriptive is trying to use all those insights you have got to be able to prescribe something. So that is the main concept of our recommendation system. So similarities help us be able to do something like that, to be able to recommend something because the words are similar, be able to build recommendation system. Again, help us to do data pre-processing. That word I can't pronounce it. So like pre-processing is like I'm trying to remove duplicates from it. So the normal model allows you to do it, but in case you want to do it in a better way, a more accurate way, this is accurate, but to become more accurate, you just need a larger English model library. Okay, model. So let's see how to do that. So we're going to import SpaCy and then create an NLP object, and we're going to create our first object. So doc1, then NLP object. We're going to compare a word like wolf, and another word which is going to be doc2 NLP. Then we're going to compare wolf with dog, right? So perfect. So to compare these two objects, just go with doc1, then dot similarity, right? Then the next one is going to be dog2. So we're going to be comparing the two of them. Perfect. So this is 0.6. That means that this word dog and then wolf are not that similar. So the higher the number, right? That is, if the number is 1, that means it's identical. If it is lower, that means it is not similar. It is reducing in similarity. That is the main thing. So let's take another example. Let's compare something different. Some words which are like almost the same. So a word like dog2, let's call it dog3, and then another word like LP. Let's compare a cat rather, right? Then we check the next one. So if I do the same thing for this and copy this one and paste here, so we are comparing a dog and a cat, right? Realize that this is higher than that of a dog, right? That of a wolf and a dog. So we can do that one to be able to check similarities in between them. This similarity can also be used for words. This is semantic similarity. So let's use a different word. So dog 4, and then we're going to create another word, right? This is going to be a word like smart. You know the word smart and then the word clever are almost the same. They have the same meaning. Semantic, right? So let's check to see how similar these words are. So this is going to be clever. Woman in whiskey. Okay, perfect. So we are comparing two words. So if you want to check for how similar these two words are, you can just use the same thing, and then when you do that, you're going to see how similar they are. So 4 and then 5. You are comparing clever and then smart. Perfect. So that is almost higher than this one. That means that the words smart and clever are more similar, right? They are more similar. Okay, so perfect. So now let's see, guess you have a lot of words and you want to compare them together. You can just do that in this format. So it's going to be, let's call it as ES1, then we're going to call it as NLP. I'm going to create some words. So we have a word like wolf, we have dog, we have wolf, dog, cat, bird, and then fish, right? We have 4 words. I want to compare them but to see whether they are similar or not. So to do that, just go with for token 1 in ES1, right? Then we're going to do the same thing. So for that is going to be the first one. We are comparing the first one, and for token 2 in ES1, we're comparing the first one, the first token with the second token, the first, then in that sequence. So print, I'm going to print the word. Let's do it this way: token1.txt, that is the first token, then token2.txt. Perfect. Now from here we're going to be, let's create something to make it similar. Similarity, and then we go with this format. So we're going to be token one dot similarity, then token 2, right? So if you print it like this, it doesn't give us any error. Perfect. So that it's printing it well. And you realize that woof is 1, so 1 means that they're identical. Then wolf and dog are not all that similar. Wolf and cat are far different, and it goes like that perfectly. Dog and dog are similar. So this is quite nice, but in case you want to actually visualize it in a better way, you can use DataFrame. You can convert this thing into a list and then pass it into a DataFrame, right? So let's see how to do that. So let's convert this one into a list. So I'm going to call it as my list. It's going to be simple, and as I said, the simplest way is just start from the back. You copy it like that to create a list from a for loop. Is just simple. You can start from the back. From here, let's take this one out because we don't need this. Then here, right? So yeah, you have taken the first one, that is this last one, and then we move on to the next one, and then we move on to the next one like that. So that is my simple way of creating a list. Okay, this is actually going to work anyway. So perfect. So if you go straight, go to create. I missed something. Okay, I missed something there. Okay, perfect. Yeah, perfect. Now I just created my list. So if I go with my list, so it has printed it perfectly for us. Woof, just like the previous one we had here, right? But in a list format. So now we can now pass this one into a data frame. So let's check that one. Since this is a list, you can pass it into a data frame. So let's call it as import pandas as pd, and then we're going to create our data frame, and I'm going to contact pd.dataframe. I'm going to pass in my list. So it's going to create a data frame object for us. So if you check for the head of it, perfect, it's working. Woof, perfect. Now with this, you can just check for this correlation, and then it's going to only work for the numbers because these ones are nowhere. So if you check for the correlation for this, it's going to only print for the one for the similarity, which is 2, right? So which is not the best way. We have to check for the correlation for the entire stuff. So we can just change these ones from token into so df.columns. This is going to give us this, but we want to change it well to make it better. So I'm going to call it as df, right? That's the column, that is the column name that we have. So I'm going to change it from token, let's make it capital token 1, and then the next one is going to be token 2, and then the final one is going to be our similarity, right? So similarity, perfect. So now it's working. So now we have our work perfectly working. Token 1, and token 2. Now let's see how to plot this one. But to plot it, we have to first of all convert these ones into words, because convert them into vectors, because it will not be able to plot it very well. So now let me reduce this, and then now let's compare them. Let's convert them into, let's encode them. So you can just do it like df.replace, so df this for visualization, to df.replace. Then what we'll be doing is we're going to be replacing the word that we had wolf. So let's call it as in this one, right? Let's just print the first 5 so that you see. So wolf, dog, cat, bird, and fish. So wolf is going to be, now you have replaced it. So if you want to plot it, just you can use a normal matplot. So import matplot.plot as plt, then import cbone, and then we importing this one to be able to run it. Well, using this one to run it, perfect. Now let's see how to plot it with a correlation. So it's going to be simple. So we're going to call it as plt.figure. We're going to create an object, and then we're going to call it figure size, then 20, 10, right? We're creating S. Then we move on to the next one, which is going to be CNS or cbone. Then we're going to use heat map to do that. So heat map. Then we're going to plot it as df this, and then we're going to .call for our correlation. We're going to set annotation to be true, and not is going to be true, right? Perfect. So let's plot it. Okay, go to X. Perfect. So now, see that now it has plotted it in a very nice format for us than the previous one. So now you can be able to see that this is going token 1, and then it moves on perfectly like that. So that is one way of plotting it in this format, right? So you can either plot it this way, or if you want to plot it in a different way apart from this, so you can also do it without the correlation, and then it's going to give us totally different stuff. So let's go off the correlation. Let's plot it, and it's going to give us something totally different, which is this, right? Okay, so by this, be able to understand it in a better way. You can just do a little correlation so that you understand it, to understand the similarities there. So thank you for watching. If you have any question or contribution, you can just put inside the comment section so that everybody can benefit. Please don't forget to subscribe. Stay blessed.